Hi everyone, welcome you back to my another video series. Today I'm going to talk about Nand Gate. So Nand Gate it is also a logic gates, but basically it is a combination of two gates, namely as AND gate and NOT gate. So by combining these two gates, it will form a NAND gate. So I have already made a video regarding the AND gate and NOT gate. You please go through that video and then follow these NAND gate videos. Now this is the truth table for the AND gate, and then this is the truth table for the NOT gate. Whenever there is any of the input as 0, the output will be 0. When both the inputs are high, that is 1, then we are going to get the output as high in the case of AND gate. Regarding the NOT gate, it inverts the values. So whenever there is 0 in the output, we are going to get 1, and whenever 1 is applied in the input, then we are going to get 0 as output. So by combining these two truth table, we can get the output of the NAND gate. So let's begin with this NAND gate. So like when we have applied 0 0, okay, let's consider this first scenario. When input is given as 0 0, here 0 0 is given. So in the truth table of AND gate, if 0 0, then the output is 0. So in the output out here, it will be 0. Now this 0 is the input to the NOT gate. So what is the input to the NOT gate if 0 is given? In the output, we are going to get 1. That means this NOT gate will invert the value of 0 to 1. So hence, we got the value as 1. Similarly, if 0 1, if we have given A as 0 and B as 1, then in the output we are going to get 0 because of the AND gate truth table 0 1. Okay, the output is 0. So output as 0. Now 0 is given as an input to the NOT gate, then output will be definitely is going to be 1. So out here it's 1. So likewise, we are going to follow this truth table. Okay, and then let's go for the last one. Let's consider this 1 1. Whenever you give 1 and 1 as input in the AND gate, if you see here 1 1, the output value is 1. So here in the output of AND gate, it will be 1, but this 1 is going to be given as an input to the inverter, that is the NOT gate. So when you give 1, then because of the inverter or NOT gate, it will invert the values to 0. So see, in the NOT gate, if it is 1, then it's getting 0. So the value will be 0. I hope you have understood this concept. Now let us write down the code for the NAND gate. So let us write down the module and name of the module as NAND gate, and then in the port list we have to declare the signals. After that, we have to declare which are the inputs and output signal. So input is A and B, these two are the input signal, and output register Y. I'm going to use the behavioral style of coding, so I'm going to write with this always at the rate of A or B, begin, end. Now this case, like A or B, this is sensitivity list, so we can, instead of writing A or B, we can also write down always at the rate of asterisk. Okay, so this means that whatever signals are there in the sensitivity list, all the inputs will be included like that. So you can use this one, or else you can use this one, anyone you can use it. Now we are going to write down the conditions. So if the signal, that is A, is equal to 1 and logical B is also equal to 1, then in that case the output must be 0. Else, if A is equal to 1 and B is equal to 0, in that case the output must be 1. So I'm going to just copy this one, this same line, and then here if A is equal to 0 and then B is equal to 1, then in that case also the output will be 1. And then lastly, else Y is equal to 1. That means if both the inputs are 0 0, then the output will be 1. So this is the design part of the NAND gate. Now we'll write down the test bench for this NAND gate module and test bench and module. So like we always used to do, the inputs will be declared as reg, so A, B, and then the outputs will be declared as wire. After that, we have to instantiate the design into the test bench. So NAND gate, and name of the instantiation as DUT. We can give any name, and then in the port A, B, and Y. So we have to initialize with the values. So initial begin, end. So in generally we can use two methods in order to give inputs. One is manually we have to give the signals, we have to give the inputs, or else the other method is to give in a random basis. So like in this case I'm going to give the value as a random process, so I'm going to use let's give for five transactions like that, begin, end. So I'm going to use for random process, okay, generating random values. So concatenate A and B is equal to $random. So they are going to generate a random values, okay. It will generate a random values for the inputs, that is A and B, okay. And then this is going to apply into the design. Let's give some delay of 1 nanosecond, and then after that let us also use one method to view the output and inputs. So that is the method of $monitor. Initial $monitor, and then write down A is equal to, for my specifier of binary, and B is equal to binary, and Y in binary. So we're going to view the signals in the form of binary, A, B, and Y. So this is the end of the test bench for the NAND gate, and this is the design. Let us choose the simulator, and then let us run this code. So basically this print is happening because of this $monitor, okay. So here we can see the output and inputs. Let me bring out the picture. See the truth table, okay. See this truth table and follow this one. If it is 0 0, then if it is 0 0, then we are getting the output as 1. So here 1 is 1 we got, and then if it is 1 1, then output is getting a 0. So 1 1, output is getting a 0, okay. And then let's take one more, 0 1 0 1, so output is 1. Similarly here 0 1, the output is 1. So this is the working of the NAND gate. I hope you guys understood. Thanks for watching.